are given real-world data. So we're going to talk about how we can write an exponential function using exponential regression. Okay? Now, the reason we will have to use exponential regression because this is not going to play nice with us. Okay? Now, before, when I gave you a table and I asked you to write an exponential function, all you had to do was identify the a, right, which would have been 6, and then identify your b. But guys, here's the problem for this particular problem. My b is not consistent. Because if I do, if I do 17 divided by 6 here, that's going to be times 2.83. If I do, 6 times 2.83. If I do 56 divided by 17, guys, my b value is not consistent. Do y'all see that? If I do 158 divided by 56, we get 2.8, times 2.82. So guys, this right here is a real world example. So we can't use our a because we don't have a consistent b. So we are going to need to put this data into our calculator to find the curve that best fits. Because if I graphed this data right here, it would look like an exponential curve, but it doesn't fit it exactly. So we want to find the exponential curve that fits it the very, very best. So how we do this, guys, is we're going to do this with the same steps that we use for linear regression. Okay? We're going to put all of our x values in list 1 and all of our y values in list 2. So this gives you a little refresher on the directions here. You go to your stat on your calculator. You go and you edit your lists. I've got stuff in my lists, so I need to clear it out. And I'm going to enter 0, 1, 2, 3. I'm going to enter my x values in my list 1. I'm going to enter my y values, 6, 17, 56, 158, into my list 2. Those are all my y values. Double check them, make sure they're good. Yes. Now I'm going to go over here and I'm going to calculate it. So this is the exact same steps that we use for linear regression, but we're using it with exponential regression now. So I'm going to go to stat and I'm going to calculate. But I don't want to calculate linear regression. I want to scroll all the way down until I find this xreg. That stands for exponential regression. I'm going to hit enter, scroll down and hit that calculate there, and this gives me my a value and it gives me my b value. So my a for my line of best fit would be 5.915, or because it says round to the nearest hundredths, 915, I'm going to make that 5.92. Are you guys okay with that? All right, 5.92. And then my b value here is going to be 3.005, so I'm going to round that to 3.01. Okay? So if we have our a and we have our b, then we can write our equation. So we have 5.92 and then parentheses 3.01, and that is going to be raised up to the x power. Do y'all feel good about that? It is literally the exact same steps as linear regression, but now we're doing exponential regression. The only thing that's different is you do exponential regression instead of linear regression. Do y'all feel good about that? Okay, awesome. So let's do an example here together, and then we will look at these on the, and then we'll look at them on the homework, okay? So if we go here, we want to write an exponential function given this data. So guys, state whether it's growth or decay. So we're going to have to state a few things. A cup of soup. Oh, wait, before we do that, can we go up here, guys? Was my b value bigger than 1? Were my numbers going up? Were they representing growth? Yeah. Look at that. That's bigger than 1. Those are growing. All right, real quick, let's look at these. This talks about a cup of soup that's left on the countertop to cool. So it was either just taken out of the microwave or just taken off the stove. And what they did was they measured the temperature of the soup at 0 minutes, 2 minutes, 4 minutes, 6 minutes, 8 minutes, 10 minutes. I don't know about you guys, but I cannot eat something like straight out of the pot, okay? I have to let it cool down for a few minutes, okay? And so, question, is my temperature getting bigger or smaller? It's decreasing. So is this going to be decay or is this going to be growth, you think? Probably decay. We hope so. I'm going to just kind of underline that. I think it's going to be decay. But let's go ahead and put in our values. So guys, we're going to put all of our x values. All the time goes in list 1, and all the temperature goes in list 2. So I go here and I go 0, 2, 4, 6, 8, 10. Okay? And then 180.2, 165.8, 146.3, 135.4, 127.7. Oh, wait, I missed one. What did I do? I missed 146.3. Oh, I just didn't do the last one. Okay, 110.5. Okay? Then you go stat calculate. Now we're going to go all the way down and find that exponential regression. We want to calculate that right here. So now my A value is 180.3. We're going to go say 38. If it doesn't tell you what to round to, just round to the hundredths. Give it 2 decimal points there. Your B is 0.95. So guys, does that represent growth or decay? Were we right? We were right. It's decay because it's smaller than 1. So my equation is y equal to 180.38 times 0.95 to the x power. Do y'all feel good about that? Okay? And then we want to use this equation to see what the temperature of the soup will be in 20 minutes. Okay? So my x is going to be equal to 20. Okay? Personally, I probably would eat it after about like 8 or 10 minutes because I still like it hot. I don't like it like burning my tongue. So let's see what the temperature would be after 20 minutes, okay? This would be like for my children, all right? So here we go. So what we would do is we'd plug all this stuff in, and we want to round our number, our final answer to the nearest tenth. So we're going to say y is equal to 180.38 times 0.95, and we're going to raise that to the 20th power. Once again, guys, these are the kind of things you're going to need your calculator for. So you do 180.38 times 0.95, and we raise that up to the 20th power. Yikes, 64.66. So my final answer, 64.66, but it says round to the nearest tenth. So it's going to be 64.7 degrees Fahrenheit. So after 20 minutes, it's 64.7 degrees Fahrenheit. Do y'all feel pretty good about that? Okay, so guys, with exponential regression, if you can do the exact same steps that you did for linear regression, and you should be able to get your answer there. All right, so what I'd like you guys to do is I'd like you guys to go ahead and try to do numbers 2, actually not try, I want you to do it. I want you guys to do numbers 2 and 3 on the back here on your own. Type in list 1, list 2, and then list 1 and list 2. You're going to do it for both numbers 3 and 4. I want you to pay attention. Use your common sense. Is it going to be growth or decay? Do my B's actually make sense? All right, guys? I want y'all to look at those. Okay, so I want you guys to do those on your own with your calculator. I'm going to put the answers up here so that you guys can see those. And you can check yourself. Don't just copy down the answers, though, because if you aren't able to do it, then you're not. But I want you guys to check it, okay? Make sure your decimals are right and all that good stuff, okay? So I want you guys to be able to check your answers. You guys can see what you've done. Recognize if it's growth or decay, all right? This one right here is for number 2 up at the top. All right. This one is for number 3 right here. So you guys can see what our lovely answers are. Okay? So you guys can check your answers there. Once you have checked those, you guys can get started on your homework.